Before we do our first hypothesis test, let's first do some preliminary work, some notation, an overview, a quick overview of the normal distribution, and then we'll talk about the steps involved in a hypothesis test before we actually do one. So first, notation. Alright, we're going to deal with averages here. Alright, so we'll first talk about the average itself. Right. Note that this is also called the mean. And we'll also talk about the standard deviation. Alright, so first for the population, and then for the sample. Alright, the population average or mean is given by the Greek letter mu. Looks like a U, but sometimes people write it like an M, which is like the Greek letter M. The sample version of that is X bar. Population standard deviation, alright, true value, which we saw in 214 is Greek letter sigma. The sample standard deviation is the Roman letter S. We also care about the size of the sample, not the population really. So we'll leave the notation off, but the sample size is given by n. Alright, let's give you a little bit of background on the sampling distributions so that you know where we're coming from and where some of these symbols fit in. So first let's talk about the population, that is the distribution of all possible x's, just random variable. Alright, this population can have any shape we want. I've purposely not drawn it like a normal distribution. We're interested in the mean of that distribution, of course as above mu, and the standard deviation of that distribution as above sigma. And now hypothesis testing. Don't know where mu or sigma are, so what we do is we use sample information. And what we have material in 214, and this is of course not drawn exactly straight into scale, but this is a distribution of all possible sample averages x bar, and is called a sampling distribution. Not sample, but sampling distribution. The first one, which I didn't label, is the population distribution. Now, it turns out to be very, very helpful in hypothesis testing that the sampling distribution is approximately normal, and that the mean of the sampling distribution is mu, and that the standard deviation of that sampling distribution is sigma sub x bar, which can be calculated with the formula sigma divided by the square root of n. Now when we're doing hypothesis testing, we really don't know where mu is. We hypothesize and test that, but we also need the standard deviation. Trouble is we don't have normally, or usually, the true standard deviation. So what we do is we estimate this, estimated normal situations with S of x bar, which is calculated the same way as sigma sub x bar, as divided by the square root of n. Alright, sample standard deviation divided by the square root of the sample size of the sample. Alright, so in our hypothesis testing, we will have sample information and x bar, standard deviation s, and sample size n. Alright, sample size n and standard deviation, so we can figure out the standard deviation of the sampling distribution, the estimated value, and we have the x bar so that we can compare it later to a hypothesized value. Alright, that gives you a quick overview of that notation. Let's clean this page.